Alrighty then. So yesterday we were graphing functions with a given domain, so they just gave you a certain amount of points and you had to figure out its y value. Then you graph those lines. So the learning objective for today is I can graph functions with a domain of all real numbers. So that's where the line comes in, or the curve. So when you're graphing functions for all real numbers, you choose values for x, both negative and positive. That's very important. And I need a pen instead of actually just touching it. That's very important. You need good values that are negative or positive, and you evaluate for y. After that, you write them as ordered pairs, just like we did yesterday. You graph the points, and then you connect them with a line, or a smooth curve if it's a parabola. So, graph the function. First off, is this in good function graphing form? Is y by itself? No. So what do we do first?
Subtract 2.
Yep. Subtract 2. And we have y equals 3x minus 2. So make your table with your x, and then write your function rule right there. So now they are not giving you values. You have to come up with your own. And like it said up at the top of your notes, you need both negative and positive numbers. So typically, you can just use, someone give me a negative number that you would want to use. Negative 2? Okay. That's a bad 2. Negative 2. Okay, so plug that in for x in our function. So 3 times negative 2 minus 2. 3 times negative 2 is negative 6, right? Minus 2. And that equals negative 8, right? Negative 6 minus negative 2, and that equals negative 8. So then, near the right side of your table, you make your x, y ordered pair section. Then you write the two values as an ordered pair. Negative 2, negative 8. Alright, so we need at least one more negative number, so negative 1, is that good with everyone? So we plug in negative 1, in for your value, 3 times negative 1 minus 2, that equals negative 3, minus 2, and that equals negative 5. Write that as your ordered pair, negative 1 comma negative 5. And that is your second order pair. Now, really, we need 2 more positive values, but we usually want at least 5 points just to get a good graph so it doesn't do anything weird in the middle of it. So another point that you can include with your negative and positive is just 0. So plug 0 in for x, minus 2. Alright, is everyone caught up? Okay. So now we need our positive values, right? So something that you could do is just use the positive values of the negative numbers you did. So you could use 1 and 2.
Does it matter what you use?
It doesn't matter what you use, but you need at least 2 negative numbers, 2 positive numbers, and 0 is usually good fifth one. So you guys can do 1 and 2, and I'll do that with you. Alright, looks like everyone's done. Your order pairs look like mine? Cool. Then, now we have to graph the points, don't we? Okay. So, -2, -8 is our first one, right? Go left 2 because it's negative, and then go down 2. 1, 2, 6, 7, 8. There's your first one. And your second one, -1, -5, over 1, down 5. Third point, 0, -2. Since x is 0, you don't move, so you're staying on the y-axis. And just go down 2. Last one, 1, 1. And then 2, 4, 1, 2, 1, 2, 3, 4. All right, am I done? Can I just leave this graph like there, just the points? Why is that?
Just draw a line.
And why is that?
The real numbers.
Right. Your domain is all real numbers, so every single. Oh, is there a line? Yeah, so. Oh, goodness, no, don't move that. Okay, yeah, just like Jesse said, since your domain is all real numbers, you have to account for every value that goes beyond just your few points that you have here. So you have to make a line that goes outside your graph.
How do you know there are numbers?
Well, if they don't give you a domain, we just assume that your domain is all real numbers. So you just draw the line, and that will account for every real number. So if you were to plug in a number like 1.5 into your function, you could find that, and that would be on your line. That make sense? Okay. Does anyone have questions before I move on? Yes.
With picking the numbers,
Mhm.
will it still be in a straight line if you do like -7 with this and then -3 or something?
Yes. It'll
Like
Depending
if
on what
they
the-
set it up so it's still like in a straight line.
depending on what your function rule is, it'll be either a straight line or the absolute value in order to be.
Okay.
But yes,
And
depending
there's
on.
no order in this, just 2 negatives and 2
Exactly.
positives. That's
All right. Is everyone good with this side? All right, next side. Function rule or function f of x equals absolute value of x minus 1. What does f of x mean again? Exactly. So it's just the same thing. Y equals absolute value of x minus 1. Make those absolute value bars a little longer so you don't get confused, and that's not 11. Yes?
Why would you do f of x when you could just do y?
Sometimes problems will say write in function notation, and that's where the f of x comes into play. If it doesn't specifically tell you to write in function notation, y is fine. Okay. Okay, so write your equation or expression in your table. Someone give me 2 negative values we can use. Okay. And depending on the size of your graph, you kind of want to pick values that are in the space of your graph.
-3.
-3, okay. 0 is our third one just because we like 0. Now someone give me 2 positive values. 3 and 5, wonderful. Okay, I'll do the first one with you guys. So we plug in -5 in for x, so absolute value of -5 minus 1. That equals, we do what is inside the absolute value bars first, so -5 minus 1 is what?
-6.
Right, so we do the absolute value of -6. And what's the absolute value of -6, or what's this distance from 0? 6, exactly. make your ordered pair section x, y. And then just write your points you got as an ordered pair. -5, 6. Did everyone get the same thing, -5, 6? Cool. So, does anyone want me to do one more example with you, or can you fill the rest out and I'll do it with you?
Okay.
You got it? Awesome.
So when it's in absolute value bars and it's positive, do you make it a negative?
Ask that again.
Like 3 minus 1 in the absolute value bars, that would be 2 in the absolute value bars, so would you make that -2?
Nope. Remember that absolute value bars are just the distance that number is from 0. So, right now 2 is in the absolute value bars, right? So, 2 is 1, 2 spaces away from 0. Just like the negative numbers, like -4, -4 is 1, 2, 3, 4 spaces away from 0. So whatever is in the absolute value bars, whatever comes out has to be positive, because distance is always positive, right? Okay. Alright, does everyone have ordered pairs? Yep. Everyone got the same ones? -5, 6, -3, 4, 0, 1, 3, 2, and then 5, 4. Okay, now we plot our points on the graph, right? So -5, 6, you go over 5, 1, 2, 3, 4, 5. And then go up 6, 1, 2, 3, 4, 5, 6. So the first point's right there. Second point, -3, 4, 1, 2, 3, 1, 2, 3, 4. 0, 1, 0, 1, go up just 1. That's a bad point. 3, 2, go over 3, up 2. And then 5, 4. 5,
Would it be -2 or -4?
Which one? I know, it doesn't look great to me either. I'm trying to figure out what it is.
No, because the absolute value of 2, wouldn't that be -2 then?
Well, you don't have negative distance though.
No, yeah, like absolute value means distance. And so no matter what is in the absolute value bars, what comes out has to be positive. All right. Does everyone have their points plotted?
Yes.
Okay, now are we done? No, we have to connect our lines, right? So with this side, it's pretty much a straight line right through it. It doesn't go any further. And our other ones on that side, mine looks horrible, but they should make a pretty straight line that way. and you extend your lines through your graph, because we're not just solving for the values that we put in our table. This is for all real numbers, so no matter what number you put in for x, you will get something out. So that's why we keep on going with our graph.
We can even figure out why it's not making a nice V, why it's not going through all the points, because I'm noticing that on their graphs too, so we gotta figure out what's going on here. Anybody catch where there might be a mistake, or is it in our table, is it in our graphing, where is it at?
I think our positive 3 must be 3, 3 instead of 3, 2.
No, it can be 3 minus 1.
It's interesting, because they should, if we did it right, all the points should line up on our V. So,
Yeah.
Since this.
okay, well, I'll look at it for a while, and you can move on to the next
Yeah.
one, I'll see if I can figure out where.
I don't know what.
Okay,
What?
right now I'm not seeing it.
All right. Next function. Negative 2x squared minus 1. So you write your function rule in your table. As 2 minus 1. All right. Someone give me two negative values.
Negative 6.
Negative 6.
Negative 3.
Sure you want to do negative 6?
Let them do it, if you're gonna let them pick them, put it in and let them see what happens when they pick.
Okay. So let's just do this one for right now. So you plug in negative 6 for x. Negative 6 squared minus 1 equals negative 2 times 36, because that's 6 squared, right? Minus 1. What's negative 2 times 36?
62.
Yep, 72.
Negative
Just from that right now, 72, or negative 72, what's negative 72 minus 1? Is negative 73 on our graph? Not so much, is it? So, especially when you're dealing with parabolas, or x squareds, you want to pick pretty small x values so your points stay in your graph. So,
Negative 2 and negative 1.
there, those are good ones. Okay, negative 2. And 1. So let's plug in negative 2 for x. Negative 2 squared is what?
4.
Right. Yep, positive 4. And I'll just bring this one down over here. Negative 2 times negative 4 minus 1. Negative 2 times negative, or 4 is what? Negative 8. Minus 1, and then negative 8 minus 1 is what? Exactly. Now, I ran out of space for my ordered pair section, but you guys have your basic table that you know it goes right after it, right? So our first one is negative 2, 9.
Why is it positive?
Because when you take a negative one, it's
Oh.
But we're not doing that, we're subtracting, and I messed up, so it is negative 9. Thank you, Cody. It's -2, -9. Good work. All right, does everyone feel confident that they can do, or wait. Our third value is 0, right? Because we like 0. So what would our two positive values be?
1 and 2.
Exactly. So now, does everyone feel confident that they can do the next 4 points by themselves, or do you want me to go through positive one with you?
How should we
Hmm?
How should we negative?
No, we went through the negative one, so now I would do a positive example with you. Or do you guys feel like you got this? Got this. You don't, Calvin? I'll go through one with you. So let's do positive one. So you plug in negative, or no, not negative, 1 for x. So just substitute 1 for x, because that's where it is in our function rule. -1. What's 1 squared?
1.
Right. 2 times 1 minus 1. We just rewrite it. -2 times 1 is what? Right. And then -2 minus 1 is -3, right? Okay, I will catch up with you guys with these ones. Last one. All right. So then, after we figure out or do all of our math, we write our ordered pairs. So for -1, we write -1, we got -3 with it. 0, we got -1. 1, we got -3. And then 2, we got -9. All right. Did everyone get the same order pairs I did? Yay, nay? Yep. Okay. So now we plot our points just like we have with our other ones. So -2, 9. And all the way down there. -1, -3. 0, -1. And then 1, -3, 2, -9. Are we done? No. We have to connect them, right? So, what do x squared functions usually look like?
They probably don't know this.
They
We
don't?
haven't covered this yet.
Never mind.
What shape does it look like it might be if you did connect the dots without a ruler? No ruler on this one.
A V, ups and downs.
That
Yep.
looks like a V.
Yep, little upside down V.
Take your ruler and see if you could make it into a V. Just don't draw the line, but see if it would they line up like a V. They don't, do they? So what's close to a V that's, maybe it could be instead? Not an A.
An
An
X.
A's got
A
straight
was there.
sides too.
An X.
U.
A U actually, it's a U.
Yep. So
show
instead of
them
just
how nice-
straight lines, you will have like slightly curved ones to get all your points
It's
connected.
a nice smooth curve, you should really just be able to draw a nice U, upside down U.
Narrow.
And it's a skinny one.
It is very skinny.
We need the arrows at the end of the.
Yes, you do. Good question. The reason why you have these arrows is even though it looks like it's just gonna keep going straight down, is that if you had really big X values, your Y values would be all the way down here in your.
Do you need it on all of them?
Yes, you will need arrows on all of your lines for your graphs. Good question.
Think you know what happened with the absolute value one? We need to
No.
go back and address
Yeah.
it. Okay, and I'll come in here and address what happened with that absolute value one. Absolute value equations always do make a V, okay, they always make a V. We could not really line up our rulers, but I need you to stay with me here, because here's the deal. When you get to pick your own X values, you don't really know yet what are, the correct ones to pick. Okay, you don't really know which ones. So here's what we need to do. I want you to take, let's add a new value to this table. Let's put a 1 in there, okay? Let's do when X is equal to 1. So we're gonna have the absolute value of 1 take away 1, which is gonna be the absolute value of 0, which means we're asking ourselves, how far is 0 from itself? 0, okay? So we have what ordered pair now? 1, 0, okay? So let's go put that one on the graph. That goes right here, doesn't it? Now, can you make a V? Will it line up? Erase this one. Erase this one right here, okay? And I will put those points back. Let's have this line come down here. Let's just see if now possibly it will 5, 4. Let's see, 3, 4, 5, 1, 2, 3, 4. Now, can we get, I couldn't, but can you with your ruler, can you get it to go through those points without actually go through them? So what happens is a V has to have a turning point. We just didn't find its turning point. The turning point was not in the table. So that's what ended up happening. So typically what works, kind of usually best is if you need to keep in mind, absolute value functions have to make a V. If they don't, you gotta maybe try some more points. You gotta try some more X values. If the teacher doesn't give you the X values, you're gonna have to play around on your own until you can find where it's actually gonna turn and make a nice V. When you're doing an X squared function, you have to you have to be able to tell that that's gonna make a turn, also make a U, whether it's a U that's opening up or a U that's opening down. We should get a U-shaped graph and there's an X squared in it. What kind of a graph do you think we should get when there's no absolute value bars, no X squared, just an X in there like our first one was? What kind of graph do you think you're gonna always get then? Straight line, yeah. So we gotta kind of get in our heads, what kind of continuous graph should we get according to what the function rule has in it, okay? So that's what went wrong on this, and we just needed one more point that we didn't have in our table because you guys didn't happen to choose it is all, okay?
All right. Now, for this one. Okay. Does everyone's graph kind of look like that upside down U? Yep. All right, so before I have you work on your assignment, does anyone have any questions about this or what we have done in the previous pages? With hearing nothing, I will say no. So then, assignment is on the board. I will hand out graph paper to you all.
Oh, you weren't recording today?
No, I was.
Okay, you want to stop the recording, or did you already? There it is, I see the recorder.